students, welcome to chemistry classes. So, under this inorganic chemistry, today we are going to learn about a new lesson called hydrogen. So, this lesson present in your textbook under chapter 9. So, in this lesson we are going to discuss position of hydrogen in the periodic table, occurrence of hydrogen, isotopes of hydrogen, then physical chemical properties, preparation of hydrogen, uses of hydrogen, etc. So, first of all, the brief introduction about hydrogen. We know that hydrogen is the lightest element as well as it is present in the first position of the periodic table. First element in the periodic table is called hydrogen. Its atomic number 1, atomic number hydrogen, atomic number 1, mass number 1.008. So, number of protons equal to 1, number of electrons equal to 1. Number of neutrons is equal to 0. So, the element which does not having neutrons, that is called hydrogen. So, the hydrogen plays an important role in the chemical process as well as the manufacturing process. So, hydrogen and their importance are discussed in this chapter. So, listen, hydrogen and its position is very difficult to explain because hydrogen resemblance with alkali metals and halogens, group number 17 of halogens. Therefore, we can't able to judge the exact position of hydrogen in the periodic table. So, first I would like to explain how hydrogen resemblance with alkali metals. How hydrogen resemblance with alkali metals. Hydrogen resemblance with alkali metals in many respects. The first one is electronic configuration. Electronic configuration. We know that only one electronic configuration, only one electron present in the hydrogen. So, hydrogen atomic number 1 and only one electron present in the valence cell, the electronic configuration is 1s1. Similarly, the elements present in the alkali metals, lithium, sodium, potassium, etc. also having only one electron present in the valence cell. Valence cell consists of one electron, hydrogen consists of one electron, all the alkali metals also having only one electron present. Therefore, the valency of hydrogen readily lost one electron from the valence cell. Is the first hydrogen readily lost one electron present in the valence cell. 1s1 minus electron gives H plus. Similarly, lithium also lost one electron from the valence cell, it becomes lithium plus. Sodium lost one electron from the valence cell, it becomes Na plus. So, the electropositive nature is a second point which resemblance with alkali metals and hydrogen. The next is valency. Valency also, all the alkali metals shows the valency of +1. Similarly, hydrogen also shows the valency of +1. Then the compounds forming nature. For example, hydrochloric acid, sodium chloride and potassium chloride. Hydrochloric acid or hydrogen chloride, hydrogen exists in the +1 oxidation state, chlorine in the -1. Similarly, Na plus Cl minus, K plus and Cl minus. So, in all these compounds, hydrogen shows this hydrogen exists as the +1 oxidation as like that of alkali metals. So, this is the similarity. So, first one is the electronic configuration, is similar electronic configuration and electropositive nature and valency oxidation state. All these respects hydrogen resemblance with the alkali metal. And also the combining nature of electronegative elements, combining nature of electronegative elements. Listen, the electronegative elements, group number 17 in the periodic table. Group number 17 is called halogen family. Hydrogen combines with dihydrogen combines with fluorine gives hydrogen fluoride. Sodium reacts with fluorine gives sodium fluoride. So, a similar way halogens hydrogen combines with the halogens to form hydrogen halides. Hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. And also alkali metals, all the alkali metals, lithium combines with the fluorine gives lithium fluoride, sodium combines with the chlorine gives sodium chloride. So it resemblance with alkali metals for forming these combining with the electronegative elements. And liberation at cathode. Liberation at cathode. One point is liberation at cathode. So, we know that the electrolysis process we are using one anode as well as cathode. Electrolysis process. Here we are taking hydrogen chloride electrolysis, hydrochloric acid or hydrogen chloride. On hydrolysis gives H plus and Cl minus. Suppose we are taking 2 hydrogen chloride molecules, it gives 2 H plus and 2 Cl minus. So, this is a positively charged ion called cation and this is the negatively charged ions called anion. Cation move towards the cathode. Cathode is a negative electrode. Anion move towards the anode. Anode is a positive electrode. So, at cathode what happens? 2H plus receives 2 electron to form hydrogen. Hydrogen gas liberated at cathode. And at anode what happens? 2Cl minus lost 2 electron from the valence cell, it becomes Cl2 gas. In the similar way, sodium halide, we are taking sodium chloride. Sodium chloride gives Na plus Cl minus. Suppose we are taking 2 molecules of sodium chloride means 2 molecules of Na plus and 2 molecules of Cl minus. Here also it is a cation. This cation move towards the cathode, this is anion move towards the anode. So, what happens? Sodium is liberated at the cathode. Here hydrogen is liberated at the cathode. So, in this way liberation at the cathode, the compounds liberated at the cathode is similar between alkali metals and hydrogen. During the electrolysis process, hydrogen is liberated at the cathode. From the compounds of alkali metals hydrolysis, this metal atom is liberated at the cathode. This is similarities. And also reducing agent. Hydrogen acts as a reducing agent is boron trioxide. Suppose we are taking boron trioxide reacts with the hydrogen, it liberates boron as the product. So, in all these respects hydrogen resemblance with the alkali metals. Now, how hydrogen resemblance with the halogens? Now, we are going to discuss resemblance of this hydrogen with the alkali metals, noble gas. This group number 17, fluorine, chlorine, bromine and iodine. What is the resemblance between this group number 17 and this hydrogen? So, here also we are taking some examples. First one is electronic configuration. First of all, electronic configuration. hydrogen only one electron present in the valence shell, therefore electronic configuration 1s1. Fluorine atomic number 9, 1s2, 2s2, 2p5. Here also one electron less to attain the stable configuration, stable state. Here also hydrogen needs only one electron to attain the stable electronic configuration of nearest inert gas. Suppose hydrogen attract one electron to the valence shell means it becomes 1s2, it has the electronic configuration of helium. Fluorine 7 electron present in the valence shell. Suppose fluorine receives one electron from their valence shell means it attained the nearest inert gas configuration of neon. So in this way hydrogen resemblance with the halogens. And the next is ionization enthalpy. Ionization enthalpy, hydrogen source, we know that ionization energy increases from left to right. Left to right ionization energy increases. Hydrogen is the first element, it shows somewhat lower ionization energy when comparing with this halogen family. But in the case of for example, this hydrogen shows the ionization energy of 1312 kilojoule per mole, fluorine 1680 kilojoule per mole. The values are somewhat very close to each other. In this way, this hydrogen resemblance with the halogens. And the electronegative character, I already told you the electronegative character. Hydrogen receives one electron, 1s1 plus electron means it becomes H minus. Fluorine receives one electron means it becomes F minus. Chlorine receives one electron means Cl minus. So this is the electronegative behavior. Hydrogen resemblance with halogens by the electronegative behavior by abstracting one electron towards its valence shell. So all these respects hydrogen resemblance with this halogens. So first we discuss how hydrogen resemblance with alkali metals. So after that we discuss how hydrogen resemblance with this halogen family. So strictly we are speaking about this, we are very difficult to locate the exact position of hydrogen in the periodic table. Suppose it may be located in the halogen means in some respects it entirely differ from this halogens. It is located in the alkali metal means in some respects it entirely differ from the rest of the family members. So hydrogen should be located in the separate position in the periodic table. Now occurrence of this hydrogen. Hydrogen is the most abundant element present in the universe. Exactly more than 70% of hydrogen is occupied by the universe. And also is hydrogen present in the form of earth crust in the form of water. Hydrogen combines with oxygen gives the water. One of the major component of water is also hydrogen. In the atmospheric air, it is the third most abundant element present in the earth atmosphere. Earth atmosphere third most abundant. So these are the some occurrence of this hydrogen. Now isotopes of hydrogen. What are isotopes? What are the different types of isotopes? What are isotopes? The elements having same atomic number but differ in mass number, that is called isotopes. This hydrogen source or hydrogen forms three isotopes or exist in the three isotopes. First one is the protium, deuterium and tritium. Isotopes of hydrogen. Protium is the normal hydrogen. Protium is the normal hydrogen. Protium, the symbol is H11, and deuterium H21 or D21. Tritium tritium H31 or T31. So hydrogen is a normal isotope of this hydrogen. Protium is the normal isotope of hydrogen. Its symbol H11 and it is represented like this. So 1 proton and 1 electron, 0 neutron, no neutrons are present. In the deuterium it is represented like this: 1 proton, 1 neutron and 1 electron. Tritium is represented like this: 1 proton and 2 neutron, 1 electron. It is a normal form of hydrogen. 99.95% of total abundance of hydrogen exists as normal hydrogen. Normal hydrogen is the most abundant among the percentage of hydrogen. Deuterium is a very rare amount, very rare quantity of deuterium exists as in which deuterium is a very low content. Low content of deuterium is present in the normal hydrogen. It is exists as it is 1H12 or D12 deuterium, or it is said to be heavy hydrogen. Deuterium is otherwise known as heavy hydrogen. It is ordinary hydrogen, it is a heavy hydrogen. Tritium is a radioactive form of this ordinary hydrogen. A radioactive isotope of ordinary hydrogen is tritium H13, atomic number 1, mass number 3, or it is tritium T13, radioactive in nature. The lifetime, half-life period of this tritium is 12.3 years. Half-life period of this tritium is 12.3 years. So these are the isotopes of hydrogen. So what are the isotopes? What are the types of isotopes of this hydrogen? So hydrogen exists in the 3 isotopic forms. Among this, the most stable and large quantity abundant is this protium. Relatively rare abundant is deuterium. Extremely very rare, trace amount of tritium only present in the atmospheric air. And also hydrogen is the most abundant in the proton-proton chain reaction. It was greatly obtained by the proton-proton chain reaction. The ordinary hydrogen is highly obtained from proton-proton chain reactions. So this reaction takes place near the sun and stars. Finally, it provides large quantity of hydrogen as the byproduct. Okay. So in this module we learn about this position of hydrogen in the periodic table, how hydrogen resemblance with alkali metals, how hydrogen resemblance with halogens, and somewhat differ in both alkali metals as well as hydrogen. Why hydrogen is not placed in the alkali metals or halogens, and occurrence of hydrogen, and what are the isotopes of hydrogen. You can go through these topics in your textbook. If you have any doubt, you may ask. Thank you.